All right, so here we go doing some basic trig identities. A lot of these today you're already going to know, which is fine. These are called the reciprocal identities because they are reciprocals of each other. For example, we see this very first one on the top left is cosecant of x is really just 1 over sine of x. It's the same thing. So for example, if we knew cosecant of some angle x was, I don't know, we could say 2, then we know that sine of that same angle x would be 1/2, right? You just take the reciprocal, right? Now that works for cosecant and sine. They are reciprocals. Same with secant and cosine. You can see they are reciprocals. And I think we already knew cotangent and tangent. And these are basically the same thing, just written the other way from up above, right? So this is really nothing new for us because we've seen that. That's how it all works. Those are reciprocals. No big deal. So with that in mind, if tangent of x, again, it does have to be the same angle. So there's tangent of some angle, x we're going to call it, is equal to 0.8. What I would like you to tell me, without the use of a calculator, is what would cotangent then need to be? Now we don't even know necessarily what quadrant this is in, correct? But tangent and cotangent are positive and negative in all the same quadrants. Now I would look at it this way, that really, how would you read that number to somebody if you had to read it to somebody? Okay, somebody gave me the answer, but let's go a little bit slower. Yes, the answer down here is going to be 5/4 eventually, but how would you read it? Yeah.
0.8 is also equal to 8 over 10.
Exactly. 8/10 is how you would read it to somebody. Exactly. Otherwise known as 4/5 if you simplify it, right? Very good. And so then, as I was told, the answer down here would then be 5/4, right? No problem. And it's hard to believe, though. Look at that. What that's telling me is that 0.8 and 1.25 are reciprocals of each other. Which I don't view them that way, correct? But they are. Okay. All right, how about this one over here? We have to see, though, if the reciprocals work. Secant of x is 3/4. Again, angle is x. Over here, the angle is x, so we can talk about it. Are those two reciprocals of each other, secant and cosine? Are they actually one of the reciprocals? Yes, they are. And so cosine of x would then be 4/3. Again, you notice that we're not concerned about what quadrant it is because these reciprocals will be positive in the same quadrants and negative in the same quadrant. So we're not too worried about that. But again, keep in mind that when I was taught this, I didn't even know that quadrants were a possibility. I didn't even know, oh, it's positive here, negative there. I was just kind of following. So hopefully this makes a little bit more sense to you how this all pieces together. Okay. Quotient identities. Tangent is sine over cosine. Again, notice it is the same angle each time. You know, I can't put an x here and then a y there and a z here. You know, it's always the same angle. And then we know cotangent then is cosine over sine. Once again, that's kind of one that we know. Why do you suppose they call those the quotient identities then? What made them? Because we had reciprocal identities because they are reciprocals. So this is probably a quotient of some kind. And what is a quotient again? Yeah, the solution to a division problem, right? Okay. So far, nothing all too new. All right. Here is where the new begins. And I have to tell you, this one here, you may want to highlight or star or something. That would be one of them that I would like you to know very, very, very well. Okay? That sine squared plus cosine squared will equal 1. And I'm going to prove that to you. I'm going to show that to you. The other two are important. But what I would say for the other two is if, for example, this one, if you see a tangent squared and a 1 kind of just hanging around, come back to these and look it up. Okay, find out that it can be replaced by secant squared. Or here, if you see maybe a cosecant squared and a 1 hanging around, maybe come back to these. All right? And one thing I think people fail to realize is that I can rewrite this. For example, that and you can write this down or not, it's up to you. That and that are the same thing. How is that possible? How are those two the same thing? They are equivalent. Yeah. Exactly. I just subtracted the cosine squared over, right? I mean, so there's no rule that says I can't do that. What if I wanted to subtract the sine squared over instead? Can I do that? Sure. What if I wanted to subtract this 1 over to there? Can you do that? Yeah, you see, all the algebra stuff still works. Okay. Now, one thing very important for me to share with you before we go any further is it's kind of a lazy thing that mathematicians have done, is what sine squared of x actually means. What it actually means is take sine of x, whatever that happens to be, and square that answer. Now the reason that we don't like that one on the right is that we don't want to write the parentheses every time. We really are that lazy that we said, well, instead of writing the parentheses every time, let's just put the square here. Ah, that's a great question, and that's where I was going to go next, is to ask you, what would be the difference of that? Okay, so let's talk about this as far as trigonometry is concerned. Okay, in this one here, I would put some angle in, correct? Then take sine of it. Then once I got that answer, what would I do? I would square it. In this case, I have some angle, which I'm going to square and then take sine. Do you believe they could give you the same answer, right? But more than likely, they are going to give you different answers, right? Okay. So any questions so far? We've gone kind of fast, and this one here is huge, though. Sine squared plus cosine squared equals 1. And I'm going to show you right now a way of remembering that, if you happen to forget it. And, ooh, that's pretty good. That might be one of my better ones right there. Oh, look at it. It all boils down to the unit circle. No way. All right. So let's just pick a quadrant. I think first quadrant's a pretty famous one, right? People kind of like to deal with that one, right? Oh, there's a right triangle. Wait a minute. Pythagorean identities. Normally when we think of Pythagoras, or the Pythagoreans, what do we think of? Pythagorean theorem, okay? Which is a squared plus b squared equals c squared, correct? And so if we're at the unit circle, we know one of these measurements for sure of this red right triangle that I made. We know the hypotenuse, correct? What is the measure of the hypotenuse if we're on the unit circle? 1. Are you in agreement? Do you agree on the unit circle that this y value, and we'll just call this x right here, that y value is just sine, correct? Because whatever I put here, it's opposite over hypotenuse, right? And hypotenuse happens to be 1, right? So this is, whatever that is actually the sine value because it'd be over 1. What's this value right here? It's the x value of my ordered pair, right? And that is cosine of that angle. So wait a minute. This side here is cosine. This side here is sine. So cosine squared plus sine squared, if I put it in Pythagorean theorem, right? A squared plus b squared has to equal c squared. You see that? So sine squared plus cosine squared, which is a squared plus b squared, has to equal c squared, but c is 1. So when you square it, you get 1. Okay, that one truly is hugely important. I can't put enough colors around it. Okay, so far I have 2, right? I can't put enough colors around that one for you. Or the Pythagorean identities in general. Very, very important. Question so far? Feel free to ask them. This is different. This is much more of an algebraic approach to trigonometry. Before, I'd say we had a very geometric approach. Okay? And I'm going to actually show you both approaches on this one. Okay? You're going to really want to stick with the way we've done it before. You're going to want to stick geometric with the pictures. Okay? But I'm going to show you how to do it algebraically. So right here, I'm being asked to take some information about tangent and give information about cosine. Right? That's really what's being asked? Well, unfortunately, if we're going to go strictly algebraic, we look back here for any help, and we're going to get rid of all this stuff. And we look back here, and we try and find any place that tangent and cosine are specifically written together. And the best, it almost seems like the best place for us to go would be there, correct? Because I can kind of see tangent and cosine in that problem. The only problem is I have tangent, I don't know cosine, and I don't know sine. That's a huge problem. So algebraically, going there is not a good plan. Believe it or not, we're actually going to go to that one. Well, why would I choose that one? I've got tangent. I'm being asked to give cosine. Why is this one going to be helpful in finding cosine? It's going to give me secant, which is the reciprocal of cosine. All right, so let's write that one down. Once you see one of these, it's all going to make sense, hopefully. So we know that tangent squared of some angle plus 1 is equal to secant squared of that same angle, right? But again, this is the lazy mathematician way of writing this formula, I think. So if we're going to write it more the way that it should be written, it really should look more like really, that's what it means, right? You with me on that? Now, why would I want to rewrite it that way? That seems like too much work. And let's face it, mathematicians said a long time ago, I don't want to write it that way. I don't like writing it that way. It's too much work. Well, so why would I choose to do that? Yeah.
You can see it better than you going to the tangent of your x squared instead of
Yeah. I think it is a lot easier to see it because now you have a substitution. Do I know, in this problem, do I know what tangent of x is? I know that tangent of x is 2/5. You agree? So this tangent of x right here, just this, I can replace with 2/5, right? So it's 2/5, but what do I have to do to that 2/5 according to this problem? Square it, okay? Plus 1 equals, well, I don't know what secant of x is yet. Well, we'll just kind of write it like that if that's okay. How many variables are left in this problem? 1, right? X. But here's the tricky part. Am I being asked to solve for x in this problem? I'm being asked to solve for cosine, right? So if I want to find cosine, really what I'd like to get by itself is cosine if at all possible. So what should I probably try and get by itself in this problem if my eventual goal is cosine? Why don't I get that by itself, right? If my eventual goal is to get cosine, wouldn't that be helpful? Okay, so we got that square. Well, we know how to deal with that. But what's this on the left side? Isn't this just a number? Well, why don't we find out what that number is, and then we can deal with that square on the other side. So let's come up here. How about 2/5 squared? Squaring fractions is not as scary as people think. Actually, adding and subtracting fractions is probably the hardest thing to do. So when you square a fraction, you square the numerator and square the denominator. So you take 2 and square it, and you get 4. And then you take 5 and square it. Please don't forget to square the 5. Okay, it's 25. Far too many times I've been told that 2/5 squared is 4/5. Okay, so now you got to square both. Okay, plus 1 equals secant of x squared. Well, I still don't really know what that number is, though. It's 4/5 plus 1. We'd probably like to write it as a nicer number, right? So how are we going to choose? Because 1 you can write in an infinite number of ways, right? How would we choose to write 1 then? Let's get rid of that version. Yeah, why 25 over 25? Because now we are trying to add them, right? And so if I broke that same unit, I'd have 25 out of the 25 units, where over here I have only 4 of the 25 units, right? And so how many total? Well, 25 stays now. And I have 29. You agree with me on that? And if you're getting a little nervous, I'll help you out by telling you this is probably the hardest problem we're going to do today. It's this one. They get easier as we go. Wait, whoa, time out. Where are we going? I got all this stuff on. I can't even remember what we're trying to solve for. Yeah, we're trying to solve for cosine. So am I trying to get x by itself? No. I'm trying to get secant of x by itself. Is it almost by itself at this point? Very close. Why is it not by itself? It's still squared. How do we deal with that? Square root. Over here, there we go. So secant of x equals. Now the nice thing also with square rooting is you can take the square root of fractions with the numerator and denominator separate. So the top is the square root of 29. I don't know about you, but I don't really know what that is. I could give you a guess, right? I get close. But how about the bottom, square root of 25? I know what that is. 5. Now that's almost right. It's half right. Let's put it that way. That's one of 2 possible answers. You have to think of something algebraically that we just did. We introduced something into the problem. Not quite. I mean, as far as this being what secant is, secant of x is almost that. That's one of the answers for secant of x. What's the other one? What did we introduce into the problem? Nope, it doesn't have to do with imaginary, but it could, but it doesn't in this case, right? Okay, we could. Okay, if you want to do that, we can do that quick. So here, cosine of x, and then I'll tell you, so if we switch it, it'd be 5 over the square root of 29, right? Right, we got to take care of that, right? Because now again, if you want to not worry about radicals in the denominator, take calculus, because then we stop caring at that point. But now we're going to multiply by this funny form of 1, right? Does anybody know the vocabulary term for that in this case? That actually has a name when you're doing radicals. Yeah, it has a vocabulary term. It's called the conjugate when you do radicals, right? So it's 5 square root of 29 over, well, that becomes 29, correct? And what I'm going to tell you is now you have one of cosine's answers. Same thing. You have one of secant's answers and one of cosine's answers. Because in this problem, I have failed to specify a quadrant. Well, we don't know that. It could be 3. But if that's the case, there you go, plus minus. Very good. And why is there a plus minus? Algebraically, why would there be a plus minus in this problem? We took a square root, right? And so right here it'd be positive and negative, and so right here it'd be positive and negative. Because I don't know what quadrant it's in, right? So who knows? Now, here's the part that's going to be a little painful for you. But I really need you to see that this works too. Okay? That took us a while, right? But again, I did tell you that's one of the harder ones. Based on your knowledge, we could have done this a lot faster. Right? Let me show you how we could have done this a little bit faster. But I'll let you write it down. I see some of you still jotting some information down, right? You're good? Oh, okay. Here's how we probably would have done it last week or somewhere in there, right? This is more of a geometric approach. Draw a picture, see what's going on. And we know that tangent has to be 2/5, but it doesn't specify a quadrant, right? So where is one of the possible quadrants for tangent to be a positive 2/5? It could be here, right? So let's draw that picture. Or it could be in 3, right? So we'll put x there, x there. So tangent is opposite over adjacent, right? How would we figure out the hypotenuse? This is not the unit circle anymore. This is me drawing a picture of this representation, correct? So how would we find the hypotenuse? A squared plus b squared, right? So 25 plus 4 is square root of 29. Ooh, wow, that looks like a familiar number. Can you pull cosine off of that picture? Adjacent over hypotenuse. Oh, how about that? Interesting. How about this one over here? What would happen over here? Any ideas? Well, how would you write it? This would be -5, -2, right? And right? So it would have worked out a lot faster. Okay? Again, they both work. You need to see the algebraic approach. So let's do one that's a little less scary. Cosine of x is 3/5. Find cosecant. Well, let's go back and find one for cosine and cosecant. Yeah, right here, right? Right here. Because it's got cosecant in it, right? Do you think that'll be helpful or no? Is that the place to go? What do you think? Maybe. But I know cosine. So I probably could go to that one if I wanted to. Yeah, I wouldn't. I wouldn't use that one. I'd actually use the first one. And I'll show you how. Okay? Sine squared plus cosine squared equals 1. Let's remember that. Is it okay if I just jump right to this representation? Is everybody okay with that? I really do like seeing it this way better. So if we have this, let's just substitute in what I know. I know cosine. So this right here can be replaced by what? 3/5 is correct. So that's going to get replaced with 3/5 squared. And here's sine of x. Yes?
So then, one of your next steps means you want to get sine of x, so then you figure out because where the 3/5 is exactly.
Perfect. Perfect. What was just said, for those that couldn't hear it, is if we're doing this algebraically, yeah, I want to find cosecant. So what do I really want to find in here? I don't want to find x, right? I want to find sine of x, so let's get it alone. So same steps as before, right? Let's get this out of here and try and get sine of x by itself. All right. So if we're going to do that, why don't we figure out what that is first by actually squaring it? So if we square that, we're looking at, what, 9 over 25, right? Because you got to square numerator and denominator. All right. That sounds good. Again, this one's going to be a little less scary. This one works out better, okay? And so let's subtract that out of here. Because we're trying to get sine of x alone. Okay. So very nicely, these would cancel. Okay. If I get going too fast, please let me know. Okay. Well, now we have that 1, though. This 1 over here is kind of tricky, so we're going to rewrite it. How should we rewrite it? We got lots of options, but I'd say 25 out of 25, right? So 25 over 25 minus 9 over 25 is 16 over 25, right? What's that? It does work nice. Now, why would you say that works nice? Yeah, I'm going to have to take the square root. So why is 16 25ths nice? That doesn't sound very nice. I got to take a square root of a really bad fraction like that? Yeah, they're both perfect squares, exactly. Okay, am I going too fast? Is everybody good? No? Okay, square root. This cancels. So sine of x is, again, be careful. In this problem, was a quadrant specified? No, so we better make sure that all of them, we know from our geometric experience that it could be positive or negative, right? But where does that come mathematically? From the square root, right? Positive and negative. Now, when you take the square roots, you can do them separately, right? When it's one fraction like this. And so what's the square root of the numerator is 4. Square root of the denominator is 5. Is that the answer to the question? Sine of x equals positive and negative 4/5. No, because I'm asking you for cosecant, right? How are sine and cosecant related? They are reciprocals. So it's positive and negative 5/4. Again, could you have drawn a picture and done it geometrically? Yes, you could have. Most definitely. Okay? Okay. The formula's right there. It gives you both positive and negative. Now, what if I did specify a quadrant? Then you have to say, okay, wait, time. Oh, okay, I'm in the first quadrant, so then it would have to be positive, right? And you would throw the negative answer away and be like, nope, no good. Okay? You with me on that? All right. This one, I'm going to let you in on how I do these. I'll let you go back to the unit circle like picture idea on these. It'd be very helpful. What I'm asking you to do is give me anything. Because let's face it, could I type sine of 765 degrees into my calculator? And would it give me a result? It would, right? And I would have to be in degree mode, though, but it would give me an answer. But what I would like you to do is adjust it and give me an angle between 0 and 90 and do something sine more than likely. Stick with sine for this one so that it would give me the same answer. Well, let's first figure out where 765 is. So if I go around the circle, all the way around in the positive direction, that's 360, correct? If I go all the way around the circle again, 720. Do I have enough to go all the way around again? No, right? Because 720 is pretty close, right? So how far off is it? If I'm at 720, I've got another how much? 45. Okay. So we happen to be at 45 degrees. We know that's on the unit circle. That's great. These don't have to be on the unit circle. So we know that this answer then, well, let's face it, we just know the answer is square root of 2 over 2, right? But that's not what I want you to give me right now. I would like you to say sine of what? That's between 0 and 90 would give me the exact same answer. And it'd be sine of 45. Do you agree this one, the 2 that I've circled in green, would give me the exact same answer? Are you in agreement? Okay, so that's a pretty easy one to start with because it was just in the first quadrant. Well, what if it doesn't end up in the first quadrant, right? That's a good question. All right, so let's take a look at this one. Which quadrant does that end up in? Negative 135 ends up in the... What's that? Third? I just couldn't hear you, that's all. Yep, it's in the third. About where? Well, it's at that 45 again, right? That 45 increment is right there. Well, we happen to know from our extensive knowledge of the unit circle that that ordered pair right there is both a negative, correct? But I'm not asking you to tell me that. What I would like you to do is give me, and it doesn't have to be cosine, but most people just stick with whatever one you're given. Give me something. So cosine of something in the first quadrant has to give me the same answer. Well, I know I need a square root of 2 over 2 somewhere, right? You with me on that? So where's the only place in the first quadrant that gives me that? 45. Okay. Now here's another way you could figure that out. What I do is I figure out how far is that from the x-axis? 45 degrees, right? Then go to the first quadrant, because that's what I'm asking you to do, and go 45 degrees from the x-axis. Do you see how that's the same exact number of degrees from the same axis? But wait a minute. If I put 45 degrees in here, what answer do I get for that one? I get positive square root of 2 over 2. Agreed? What do I get for this one? I get negative square root of 2 over 2. That's not the same answer, is it? It would look like the same. So how do I fix that? Because these rules state it has to be between 0 and 90. Have I met that criteria over here? That's between 0 and 90. How do I fix this problem? I need them to both give me the same answer. One of the words you said is correct. The words that were said were opposite reciprocal. Reciprocal is just going to flip it over. That's not going to help me. Take the opposite. If I do negative cosine of 45 degrees, or the opposite of cosine of 45 degrees, would I get the same answer? You would. That's a quick fix, right? Just say make it negative. No problem. Okay, we're going to do one more together, and then I'm going to send you off on one on your own. It's not on your page yet. It's going to be a letter D. All right. 315. Well, which quadrant is that in? 4. Very good. And it happens to, again, be the 45 increment. Sorry about that. But I think it's easier for us to start with those and then work our way towards the other ones. So it's right there. But once again, what I do, I truly do this. I say, how far is that? I just pick the x-axis all the time. How far is that from the x-axis? Well, it happens to be 45 degrees, correct? So go to the first quadrant from the same axis, which is the x, and go 45 degrees. All right. So apparently that's the degree measure. Now the question is, do the tangent of 315 and tangent of 45 give me the exact same answer? Well, what's tangent at 45? Square root of 2 over 2 over the square root of 2 over 2, which is positive 1, correct? Unfortunately, down here, if I do that, tangent is negative 1 down there. So this answer here is negative 1. This answer over here is positive 1. I need them to be the same answer. How do I fix that? The same way we fixed the last one. Put a negative out front, because then all of a sudden that became negative. Okay? Because I've given you rules to follow that it has to be between 0 and 90. Now, could I change the rules and say it has to be between 180 and 270? Yes, I can, and you do the same philosophy. Okay? The letter D, I would like you to add, I'm going to be sneaky, is not going to be one of the major divisions of the unit circle. It is on there, but it is not one of the major divisions. Let's try this one. And take a second or two, or maybe a little bit longer than that, and try and get that answer for me. All right, of course, if you're listening to the recording, you should actually pause it and actually try that problem instead of just waiting for me to give the answer. All right, sine of 189. Well, where's sine of 189? Where's that actually end up? 189, where are we talking? 3? Okay, so right about there-ish, right? Give or take. We can agree that sine would be what there? Positive or negative? Sine would be negative down there, right? Okay, because it's a y value, right? Okay, here's it. Truly, this is what I do. I say, all right, I pick an axis, and normally I always do the x-axis. I don't know why. And how far am I from the x-axis? 9 degrees. And then you go to the quadrant that you are being required to be in. And what quadrant did I require you to be in? The first, right? So you go to the first in the same axis, x-axis, and go the same amount. Agreed? 9 degrees, right? Okay. So I'm at 9 degrees now. Okay, stick with your sine. So sine of 9 degrees. Do those two at this point give me the same answer? Why not? Exactly. Sine of 189 is negative. We know that. Sine of positive 9 is positive. So they would give me the same decimal representation, except one would be positive, one negative, right? But that has to be between 0 and 90, so I have to get there some other way, and so you do that. Okay? Now, does this stop me from asking you any other quadrant? No. I can ask you any of them, and you go through the same process. Okay? Do you have any questions at this time? No? All right.